I want to talk a few minutes about the exam here to start, and then we'll transition into current stuff. So I have I did a draft for the exam. I worked through it, did like one round of proofread, and it looks okay. I think it took me like 50-ish minutes to do it. So that's probably pretty close on to what would be reasonable for you guys, considering you really only have to do like a little more than half of it. So again, the test is 120 points is what it settled on. Your score will be graded out of 70. You can do as much as you can, and I'm just going to keep adding points, right? So anything that you get right is like, okay, 1 point here, 2 points there. Even if it's like, oh, you got 2 out of 5 on that, it's like, well, it's 2 points, right? Everybody's cool? So the test is divided into like 2 types of questions. There's 70 points of standalone questions that are just like, do this, like find the limit, or do the derivative, or, like find the maxes and mins, or whatever, like normal, just singleton calculus question. And then there's 50 points of like multi-part questions. So think about like the more complicated topics like the related rates and optimization, or like analyzing a graph, where like that process can be kind of long and complicated, and allows me to like help you step through, leave some breadcrumbs for you, and turn like the problem into something that's like a little bit more doable. In addition, it allows me to do things like on a related rates question, be like, show that volume is equal to yada, 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 the equation that you need to use to actually do the problem. Like I can have show that, the volume can be written as like this equation. So when the next question asks you to like find dv dt, you have the correct equation. Even if you couldn't do the show part, you have the correct equation that you need to do the rest of the problem. So on all those multi-part things where I could, or where it was feasible, I went and phrased them as a show question, so that it didn't like block off the last half of the problem or whatever if you goof that piece. So then I went through the test and kind of just made a note to myself of like what the topic is for the question or questions. So this is the list there. So I have limit techniques. So that's stuff from chapter 2 plus L'Hopital. A lot of the chapter 2 stuff in L'Hopital could be used interchangeably. So the limit problems aren't going to be, say, like use L'Hopital to do this. It's just going to say like evaluate the limit algebraically, right? You should know your derivative rules, like your sine, cosine, tangent, inverse sine, cosine, tangent, polynomials, exponentials, logarithms. Should be able to remember all your derivative rules, plus like chain quotient product rules. Newton's method, which is what we'll talk about today, so you don't know what that is yet, but the limit definition of a derivative. So I will have, a question or two on there where it's like use the definition of a derivative to differentiate, blah, 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 blah. So again, remember the definition of the derivative is like the limit as h approaches 0 of f of x plus h minus f of x all over h.
Oh.
Right, that's what I mean by the definition of the derivative. Should be able to do implicit differentiation. Should know your antiderivative rules. Those will come up in 4.9. The good thing about these are, if you know the derivative rule, the antiderivative is just going backwards, so you kind of know the antiderivative rule also. You should be able to do the first and second derivative tests as well as the absolute min and max test. This is for closed intervals, the absolute min and max test, and the first and second derivative tests are really on open intervals. Should be able to use the squeeze theorem, intermediate value theorem, extreme value theorem, mean value theorem. I won't ask you to like write down the theorem, but you should be able to do a problem where you need to use that to do it. Or if I give you a, say, like like use the mean value theorem to conclude from this that you have this, but it's wrong. What did you, like, how did you use this improperly or whatever? Like, you should know the conditions that you need to have to use these things. So if I give you a problem like that, you can figure out, like, okay, why couldn't we use this? So you do need to know it, like, well enough to where if I try to trick you by using it improperly, you're able to tell that, oh yeah, this doesn't work here because of, like, that function's not continuous or whatever. You should know your definition of continuity and your continuity rules. So the definition of continuity at a point, on an interval, and then you should know your functions that are known to be continuous, like polynomials and trigs and exponentials and that kind of stuff. You should be able to graph a piecewise function. That was like a chapter 2 idea that we did a fair bit in. Chapter 2, we had piecewise stuff pop up. You should be able to determine where a derivative fails to exist. Where do they fail to exist? Where the left-hand limit does not equal the right-hand limit. Yep. So like a corner is an example of that. Should be able to do related rate problems, optimization problems, a position, velocity, acceleration problem where you're differentiating down from position to velocity to acceleration. And in 4.9, we'll see the same problem working in reverse, where you go from an acceleration problem and build up to a position equation. So that's the reverse. Curve sketching, you should be able to do that. That was like 4 or 5 stuff, where you can take your intervals of increasing, decreasing, concave up, concave down, locations of, relevant points, and construct a reasonable sketch of the graph. You should be able to do an end behavior. That's where the limit goes to infinity or negative infinity for f of x. You should be able to use limits to prove the location of a vertical asymptote. So if you think there's a vertical asymptote at 1, you need to show the limit as x approaches 1 of f of x is equal to positive or negative infinity. That's all you need. Should be able to do the increasing, decreasing test, the concave up, concave down test, and be able to find inflection points. So that was my list as I went through the test, kind of looking at the relevant topics here. I'll get you guys something else that'll be a little bit more chapter 4 heavy in terms of like specific review stuff, since we haven't had a chapter 4 test. Hopefully this week. I'm still kind of working on getting all my exams together and everything, and that kind of has to happen first, but I'll get you guys something here soon. Anise?
Would you say like the points for each chapter are like kind of even, or do you think there's probably more chapter 4 stuff than chapter 2?
What I would say is that 3 and 4 are probably reasonably evenly distributed, but there's less stuff from chapter 2 than there is from either 3 or 4. So rather than like 1/3, 1/3, 1/3, it's probably more like, 20%, 40%, 40%, if I were to just kind of make a guess. But 4 is not more represented than, say, 3, I don't think. But chapter 2 is like so much theoretical stuff, it's hard to write, like a lot of relevant questions, because like we did a lot of derivatives in chapter 2, but like the techniques we used are kind of irrelevant. You know what I mean? They're just kind of like foundational pieces. John?
Are all the standalone questions going to carry the same weight?
No.
Oh.
So they could be from 1 point to like 4 or 5 points.
Oh.
So like if it's a complicated derivative, it's like a 5-point question. If it's like, why couldn't Mr. Kulik use the mean value theorem, or Mr. Kulik used the mean value theorem here incorrectly, what did he do wrong? It's like a 1-point question. It's like either you know it or you don't, right? Like, so they'll vary. I think 5 is the most anything is worth. 1 is the least. Shocking. But there's 2-point things, there's 3-point things, there's 4-point things. Just kind of depends on how time consuming maybe it is, or how much I'm asking for. Like if I'm asking for like 3 things or 4 things, like if I want, you know, the intervals of increasing and decreasing and the extreme and like the local maxes and mins. It's like a 3 or 4 point problem because I'm asking you to do a bunch of stuff there, or a bunch of different answers, as opposed to like if I just ask you to like, you know, evaluate this limit and it's just like a direct substitution limit, which might be like a 2 point problem or a 1 point problem. You know what I mean? Like evaluate x plus 7 at 2. You know, like it's a 1 point problem. You know what I'm saying? So yeah, they're not all the questions are not equally weighted, but I have the weights for every question labeled on there, so you can know like, did I just spend 10 minutes trying to do a 1 point problem? What am I doing here? You know what I mean?
Yeah.
Those are ones that like, if you know it, do it right away, do it quick. If you don't, like, don't spend a lot of time thinking about this. Like, go work on something that has more partial credit available to you than like half a point. Like a 1 pointer is just like, eh. Anyways, everybody cool with that format and kind of at least a little bit more focus there as to what to worry about? Okay. Let's transition to some questions from homework, and then we'll talk about 4.9 or 4.8, excuse me. Blake.
So that's the second,
Yes, 4.7 was what we just did.
Doing number 31.
Sure. All right. So I would say that for all of us, if we haven't had a chance to do the 4.7 problems, even if you're still working on some of the previous stuff.
30?
Oh, 31. Did you say 30? Not this one.
Not 41. No.
Okay.
I don't think so.
Okay, that's fine. That's fine.
Either that or my drawing is really.
No.
really
You
off.
which number then? 30?
31.
31. Okay.
I think that's in the whole set. Maybe it's not.
Probably is.
Yeah, it is.
So it says a right circular cylinder is inscribed in a sphere of radius r. Find the largest possible surface area of such a cylinder. Okay. So we have like some sphere here. Right? And then inside this sphere, we have like some cylinder. Everybody happy with what we've drawn there? It says that the sphere has radius r. And we want to find the largest possible surface area of the cylinder. Okay. Everybody happy with the picture that we've drawn? Okay. So I'm going to start by just writing down the surface area formula for a cylinder. So it's the top and the bottom, so two circles. And then if I unfold the sides, that's a rectangle, right? The width of that rectangle is going to be the perimeter of the circle. So 2 pi r. And then the height of this rectangle is going to be the height of the cylinder. And I guess I'm going to put like C's on these. because there's a radius for the sphere also, and I don't want to confuse myself about which r I'm talking about. Everybody cool with this so far? Okay. So what I want to do is I want to find a way to rewrite this now in terms of a single variable, right? So this is going to be the trick here. Let's use a different color here, Kulik. So I'm going to make myself a right triangle. I'm going to call this piece y, call this piece x, and what's the hypotenuse got to be? Oh, shoot. Excellent. That's the radius for the sphere. Right? Because it's going from the center of the sphere to the perimeter of the sphere. Tough to catch that. So I can say x squared plus y squared is equal to r squared. And I'm going to start by getting the y by itself. So y would then be the square root of s squared minus x squared. Now, why did I drop the plus or minus here when I square rooted both sides? It's a length. Yep, it's a distance, it's a length. Good. What's the height of the cylinder then going to be? Yes, good. Right? So that piece has to be x also. All right. So what I can do then is I can rewrite my surface area.
I feel like I'm missing something out. Oh, wait, no, why? Never mind.
Y is the same as RC. Yep. I guess I could have used that notation, but. So this is now a equation in terms of one variable, x. All right, so I can write it like SA of x. What's the domain for this going to be?
X would have to at least be larger than 0.
Okay. And it would have to be the biggest it could possibly be is RS, right? If it was bigger than that, we'd be undefined, right? Because I'd have r squared minus something bigger than r squared that I'd be square rooting, and that's a problem. Everybody cool with that? Okay. So I'm going to do some simplifying here now a little bit. I think to make the calculus going to be a little bit easier here if I do that. So I'll write it like that. And really maybe, let's do this. I'm going to distribute that stuff through, I think. Let's do that. Okay. Now let's take our derivative. So what's the derivative of 2 pi r squared? Why? What is r? That's the radius of the sphere. Is that changing? No. The sphere is fixed, so that's a constant. That's why I wanted to write it out, to make sure that we caught that, because that's an easy mistake to make, right? And then derivative of 2 pi x squared, 4 pi x. And then the derivative of 4 pi x times the square root of r squared minus x squared. Product and chain, good. So I'm going to just pull the 4 pi out front. And then we'll do the product rule. So I'll have x times the derivative of the square root of r squared minus x squared. So 1/2 r squared minus x squared to the negative 1/2 times negative 2x. And then plus the derivative of x times r squared minus x squared all square rooted. All right, let's see here. Let's clean this up a little bit. So I noticed that everything has a factor of 4x or 4 pi in it, right? So I'm going to factor that to the front, and I'm going to end up writing this as a fraction, I think. But I'm going to just put the 4 pi times. Now, my only denominator right now is that piece, right? Ooh, wanted yellow. Because of the negative exponent. Agreed? So if that's my only denominator, that's going to be my common denominator. Everybody agree with that? If I multiply, or if I make a common denominator on that piece, I have to multiply the top and bottom by r squared minus x squared to the 1/2, which just gives me a regular old r squared minus x squared on top. Everybody agree with that? And then I have the 1/2 and the 2 are going to cancel each other out. So I just have x times negative x. So negative x squared. And then I got to multiply this piece by the square root of r squared minus x squared. Now the 4 pi is already over here. Good. Squeeze it in there. God bless you. Well, that looked like a square root symbol there too much. That looked more like an R. Okay. Everybody cool with how I've got that situated? All right. So set it equal to 0. I'll notice that the denominator can't really be equal to 0, right? Write it this way. So I'm just going to multiply both sides by r squared minus x squared square rooted over 4 pi. It's going to give me 0 equals well, I might as well write that as 2. Okay, who remembers how to solve something like this from Algebra 2? Okay, you want to get the square root piece by itself. So I'm going to add over the 2x squared and subtract over the r squared. And then I'm going to square both sides to cancel out the radical. Now the left-hand side I have to FOIL out. And then I'll distribute through my x squared. Guess I forgot that s down, subscript or whatever. Okay.
So how did you go 4?
How did I? Oh, sorry. Yep. And then we'll combine my like terms over. So I'm going to have 5x to the 4th minus 5x squared r squared plus r to the 4th equal to 0. Now notice that this guy is in the quadratic form, correct? So I'm going to just say, for example, let a equal x squared. So we have like 5a squared minus 5a, well, let's write it as 5r squared a plus r to the 4th equal to 0. So I can apply the quadratic formula that a is going to equal negative of negative 5 plus or minus square root negative 5 squared minus 4 times 5 times 1 over 2 times 5. I noticed I couldn't factor this, right? Two things that multiply to give me 5 and add to give me negative 5 are So I have 25 minus 20. So I have 5 plus or minus the square root of 5 all over 10. Oh, and really this is, sorry, that should be, let me erase this. I forgot all my r's. it's going to be 5r to the 4th over 10. Or I can just factor out the r squared. Everybody's okay with that? But we're not done, right? Because we only solve for x squared. So we'd have to square root both sides now. What do you notice there?
Can you even double square root something?
Sure.
Is it like a? Oh, yeah, okay.
What do we have to be careful about, though, when we solve an equation like that involves a square root like this? I have to be careful about my extraneous solutions. So I have 4 solutions here, correct? Now this one I can immediately discard. Why can I do that? Because it's not in the domain of x, right? X had to be greater than or equal to 0. So now I'm down to 2 solutions here. What I need to do is I need to go back to this equation before I've square rooted it and check to see if these both satisfy. Blake doesn't look happy about this at all. So
I feel like what is going on?
Yeah.
okay, sure. Let's take a time out. We're trying to find the largest possible surface area.
And this
So-
is the largest possible x value.
So what we're doing is we're solving the first derivative of surface area equal to 0 to find any critical values.
Yep.
After we've done that, then we can check those critical values using our absolute max and min test, since we know the domain is between 0 and RS. So we'll just be checking 3 values. So I have to check these critical values as well as the endpoints. So I'm just trying to find the critical value right now
Okay.
is where we're
Yeah.
at.
That makes a lot of sense.
Just the algebra has gotten nasty
Yeah.
to solve this thing.
Yep.
Okay.
So before you keep going, I just want to ask though. So that start equation right there, that is
That's what I'm going to be checking with.
okay. Can you remind? Oh, I see what you're saying. Are you talking about that equation, or are you talking about the one above it that you say equals 0?
Well, I want it where there's things on each side.
Okay.
And the reason I want to do that is because it's going to make the check a little bit easier. Since I know this is just like x times a square root, I know the result can't be negative,
Okay.
right?
Mm-hmm.
So here's what I'm going to do is I'm just going to plug this in and see if I get a negative value on the other side. Since I can see right away that 5 minus the square root of 5 is not a negative number. So I know that both those answers are positive, so that's not a problem.
Yep.
So I can square root both of them. But what I want to check here is if 2 times x squared minus r squared s is negative or not. Because if it is a negative value, then I know that's extraneous because I can't get a negative coming out of a positive times the square root.
Yeah.
I'm just trying to make my checking a little bit less cumbersome than having to plug this x into all the places there's an x.
Okay, I get what you're saying.
So I'm just trying to make my life a little bit easier. Does that feel okay?
Yep.
Okay. So we have this is where we're checking at. So this is positive, and this is positive. So what we're going to do is we're going to be plugging in over here to see what happens. And let's just start with the plus. Oops. Okay. So if I do that, the squared cancels the square root. And then the 2 can cancel with the denominator there. So I'm left with 5 over 5 plus root 5 over root 5, and then times r squared. Well, it's under the square root. Yep. Okay. Well, this is just like 1 plus the square root of 5, if I simplify that. So that's just going to give me square root of 5 r squareds. Okay. Oh. I'm so dumb. Okay, so this is fine, but here's the problem. This is going to be extraneous. This assumption that I made was a bad assumption. Because look at what x squared is. Or this 2 times x squared is this, right? So x squared is going to be, I don't know, something positive. And I have the square root of 1 plus the square root of 5 over 2 r squared s. And this piece, 1 plus the square root of 5 over 2, is going to be, this is, it's not over 2. Sorry. Let me just be a little bit more specific here. So this was 5 plus or minus square root of 5 over 10. So that'll be 1/2 plus square root 5 over 10. Right? Everybody's okay with that? This is less than 1.
Oh wait, no, yeah, 1 is not 0. Yep.
right? Because the square root of 5 is less than 5, right?
Yeah.
5/10 would be a half. So that's certainly less than a half. So what does that mean that this whole thing is? That piece is negative, and it's under the square root. Everyone's looking at me like I'm a crazy person.
So, can we just take a little quick step back here?
Absolutely, yes. Go back to where we're feeling okay.
So like, if you have if it's subtracting, it's like extraneous, correct?
If it's subtracting, it's extraneous. If we have a no, what we're seeing is we're looking, do these satisfy this? The problem is that this is a nightmare to plug in to all the x's, right?
Oh, okay, I understand. Yeah, it is a little bit.
So there were two places where this could really is likely to cause the extraneous. One would be if I have like a negative coming out of a square root, right? That's what I checked initially, and it was fine.
Uh-huh.
The other place where I could be in trouble is if I get a negative under my square root. So that was the next thing I tried to check. And that's what I found here.
Is that it is a negative?
It is a negative. So
because you're multiplying it like a less than 1 number by r.
And then subtracting
r.
r.
By itself.
Yes. So yes. So that means I can dump that one. The positive, yeah. So we should then check the negative one, which is a nightmare. Can we just say that it works? Because I'm looking at the answer key and I know that it works. We would do the same thing. No, you can't well, because it could be the endpoints of the domain also, John. That's the crummy part. So it could just be like where x is 0 or x is r, right? It could be one of those. There doesn't have to be an actual solution. There is. Here's how I know it's going to work. Is if I do this. Why would that? It was. Tegan, what's up?
So is this kind of one of those 5-pointers? It's like a 20-pointer.
Oh, I would not give you something that was this big of a pain in the butt to deal with. Yeah. And again, the algebra piece is the part that's killer here, not the calculus piece, right?
Yeah.
Doing the derivative, we're fine with. Like knowing that I set the derivative equal to 0 to solve, I'm fine with. The actual process of solving this thing is just kind of a nightmare. And what makes it a nightmare? Well, it's that there's r's attached to this, and I can't just like type it into my calculator and just go, okay, check. Did this, type in one side into y1, type the other side into y2, and just do y1 of this answer, y2 of this answer, see if they're the same thing, right? Like, that's why it's a pain in the butt. Now, I guess we could probably do that and just make r1, and I think it would be okay. So, like, we're going back to here. Let's try this real quick. Maybe that's the cheaper way of doing this. So I'm just going to make r1. Okay, and then we'll do y1 of was 5 plus root 5 over 10. And again, I'm just making the r's 1. So I get that. And if I do then y2 of the same thing, I'm going to get an error or, oops, or something, or a different value. Okay, so they didn't agree. If I go and do the same thing with the minus, I did something wrong then. I really thought that would have been okay. Anyways.
Is it because that first one is squared?
Is that because the first one isn't squared?
Can you write it?
Oh, the square root of. Yeah. I gotcha. I see what you're saying. Gosh darn it. You poop stain. Sir. I just can't stand you, you stupid machine. Like, I can't insert a stupid square root symbol because you're dumbos. All right. And make me type all this crapola in over and over and over again, huh? Drive me crazy. All right. That. That. Is this gonna work? We spent so much time on one problem. Okay. But they weren't supposed to work. That was the one that was supposed to fail. Why did it?
I think that must have been a
Take the
typo.
L off. It's okay.
Yeah.
Sometimes you just gotta throw it all in. No, it's just, yeah, it's just like best. Doesn't account for the surface area loss. I'm ready to work. Yeah, more than the lunch. There you go. So I have a question.
Oh my goodness. All right, let me just do this real quick to satisfy my own morbid curiosity. Okay. Those ones are different. So I have a negative sign dropped somewhere then. All right, I'm going to stop here because it's like we're just done. So here's what we got. So we got that x equals the square root of 5 minus square root 5 over 10. And then times r. This is our critical value. So if I do SA of 0, I get 0. If I do SA of r, I get 0. If I do SA of x, the x that I have up here, what do I get? I get, I need that stupid equation again. Where are you? This is what I want.
Shoot, can you do that? Oh, yeah.
It's like a cowboy.
It's like one of, yeah, it's one of
Yeah, I know. It's mostly such a pain because the numbers are just a terrible, terrible pain in the buttocks. Oh, you know what? All I care about is if this is a maximum or not, right? What am I doing? Right? All I have to do is check to see if the second derivative here is going to be positive or negative. Right? Yeah, so if I do the derivative again, that's what I would do there.
And then plug it back.
Yeah. Yeah. Anyways, I'm just stopping.
Yeah.
We're just
I do not blame you.
we're just done. The algebra got too messy. I quit. Luke, you had a question?
Yeah,
27.
I don't think we have time.
Okay. Is it the same section?
Yeah, I can come here and see too.
Or we can do it next time too. But I want to do 4.9 or 4.8 today. It doesn't take long to do 4.8, but I probably do need a half an hour. So I am gonna call it a quits on this one. I'll go back and look through that problem that Blake asked about when I have a minute and come up with a little bit more coherent linear explanation.
I mean, this is pretty coherent. It's just like
The algebra got real messy at the
Yeah.
end when I was trying to check stuff halfway.
yeah.
And I made some kind of mistake in there where I couldn't get it to check
Oh.
the way it was supposed to. So I'll go back and look at this. All right. 4.8 is about something called Newton's method. Newton's method is a approximation technique to solving an equation. So you know how in your calculator where you do the 0 command when you're graphing, or you do the max min command when you're graphing? Probably what the calculator is using to get those results is Newton's method or some variation of it. Would be my suspicion, is the way that it's actually coded in there. It's not actually solving these things. If you have a non-CAS calculator anyways. If you have a CAS calculator, it may be doing it algebraically.
TI-84 CAS calculator.
Not unless it has the letter CAS at the top next to the 84.
Oh, the TI Inspire.
But it's got the CAS. There's an Inspire that's not a CAS also. That stands for Computer Algebra System,
Gotcha.
in case you're wondering. Anyways, so this is just like a linear approximation method. So this is the idea. We have some function f of x. We have the actual solution here, r. We make a guess. Say x1 is my guess. So I find the point x1, f of x1, and I draw the tangent line to the curve at that point. That's the thing in pink. I figure out where that tangent line intersects the x-axis. That becomes my next guess. I do another tangent line. That becomes like guess 3. And I keep doing this, and as I do this, I should be getting closer and closer and closer to r. Everybody feel okay with that idea? That's basically what we're doing geometrically. Okay? What's the algebraic hang-up? Is how do I find where the tangent line intersects the x-axis? Okay with that? Well, this is the formula. So the next guess is equal to the previous guess minus f of the previous guess divided by f prime of the previous guess. And if you've made your initial guess, if your initial guess has been pretty good, then as n approaches infinity, your guess should approach r.
So it's like a lot of just like plugging and chugging kind of thing.
Yeah, but here's the I'm going to show you the good part in just a second. Okay, so let's do an example, right? So this is our initial guess is x1. We want the third approximation for the equation x cubed minus 2x minus 5 equal to 0. So my f of x is going to be the left-hand side of the equation now that it's set equal to 0. My derivative is that. So my second approximation is going to be my first one. I'll write it this way first. Is going to be this, right? Or 2 minus 2 cubed minus 2 times 2 minus 5 divided by 3 times 2 squared minus 2. Everybody's okay with that? And then x3 is just going to take that answer that we just got and plug it back into the formula, right? Everybody's happy with the approach here? All right. Take out your calculator. Follow along. Because Mr. Kulik's going to show you a way to do this on your calculator where you can just keep pressing, once you set it up, you can just keep pressing enter to get the next one and the next one and the next one and the next one, and you don't have to type this in over and over and over again. Everybody's happy with that idea? I love it. So I'm going to go to x1. In place of x1, or I'm sorry, in y1, I'm going to type f of x. I'm not going to do the derivative. You could. I am not going to. I'm going to let the calculator handle the derivative piece for me because all I can do is make a mistake in doing a derivative. Even though I should not make a mistake on that, what would Mr. Kulik do? He'd do something dumb and put like minus 5 at the end of that also, or something stupid like that, because he knows himself. Okay, so I have just f of x until y1. I'm going to start by typing in my guess and pressing enter. So it says my initial guess should be 2, so I'm just going to type 2 and press enter. Now I'm going to type this formula, but in place of the x1, I'm going to type ands, second negative sign. I'm going to do minus, make my fraction, and I'll do y1 of, so in parentheses, and then ands, and then the denominator is going to be the derivative. So I'm going to press math. I'm going to scroll down to the n derive option. I'm differentiating with respect to x. The equation I'm differentiating is in y1, so vars, y vars, function y1. And I'm differentiating at ands. So that's my setup. I'll press enter. That's x2. I press enter again. That's x3. I would be done. If I wanted x5, I just keep pressing enter. Here's x4, here's x5, here's x6, and I can just keep pressing enter. I get as many as I want. How lovely is that? That is so stinking rad. I can't even stand it. You know why? Because Mr. Kulik remembers when he was a student how big of a pain in the butt this was when you had to plug all these numbers in and keep all of these decimal places. Like you had to write down all the decimal places and had to type all the decimal places in. It was such an unbelievable nightmare. And this makes the process so much easier. Do you love it? I love it.
So this is what that equation is what the calculator does.
Yeah, the calculator's just gonna, like when you press enter again, it just recalls the last thing you did.
Yeah.
Which, because the only input was your previous answer, it just takes whatever the previous answer that you just generated and plugs it back in, and it'll just keep doing it, doing it, and doing it, and doing it. Just keep pressing enter. Let's do another one. It says use Newton's method to find the 6th root of 2 correct to 8 decimal places. So if I want the 6th root of 2, I need to start by turning that into an equation. About x to the 6th is equal to 2. Everybody agree with that? And I need that to equal 0. So there's my f of x. Okay, well that's easy. Okay, so I type that into y1. Next thing I need is a guess. What would be a good guess here? So let's do perfect sixths, right? 1 to the 6th is 1. 2 to the 6th is 64. What number am I evaluating? 2, right? 2 falls between 1 and 64, so this x to the 6th is something between 1 and 2. Everybody agree with that? Which one is it closer to, 1 or 2? Let's make that our guess then. 1 should be our guess. So I'll do 1, press enter, and then I'm not typing all that crap in again. I just have it up there. I'm just going to scroll up and press enter to screen cap it, and then press enter again. There's my x2. So currently, if I compare my previous answer, which was 1, to this answer, the only thing I have correct is the 1 spot, because they're the same. The decimal, everything after is different. I'll press enter again. If I compare this x3 to the previous answer, I'm now correct up to the 10th spot, but everything after that is different. I'll press enter again. So now I have 2 decimal places that are the same, but everything after is different. I'll press enter again. Now I have 4 decimal places that are the same. I'm supposed to be getting to 8, so I'll press enter again. Compare here, and ooh, look at this. I got 1, 2, 3, 4, 5, 6, 7 decimal places the same. So do one more time. Now I got 8. How lovely is this setup on the calculator where all I'm doing is just pressing enter a bunch of times? And once you've set it up once, you can use it like the whole homework set, right? I just keep enter my new guess, screen cap it in. I don't have to do it over and over and over again. What a time saver. Thank you, Mr. Kulik. You're welcome, students. So what do we have here? What'd you say?
Well, Luke was like, the homework's probably gonna be so many for home. And I said 1 through 96 odd.
Why would it be 96?
Well, I guess it would be 97, 95. I don't know.
3, 4,
That's just off the dome.
5, 6, 7. So this was the 7.
That's like horrendous. That's like so short. Oh, okay.
I don't even think I asked you to do much either.
No, you asked us to.
All right. So one more here. And then I want to show you something that can happen that's bad. Again, we're solving this correct to 6 decimal places. So first order of business would be to get it equal to 0. So that becomes my f of x. So I'll type that in. Notice that I have a cosine function in here. What mode should my calculator be in? Radian. So double check to make sure you're in radian mode. I am. Now let's figure out a guess. Assume that this is a no calculator situation. How would Mr. Kulik go about getting a guess? I'm going to start by sketching a graph of cosine. It's pi over 2 there, right? Just from trig. And then I'll sketch in a graph of y equals x. Probably right. Everybody's okay there? Where's the this is what I'm looking for is my solution, right? That's going to happen between 0 and pi over 2. Pi over 2 is about 157. So what's my guess going to be? Well, just 1.
Sure.
It doesn't really matter. For this one anyways. Everybody's cool with how I came up with 1?
Yeah,
Yes.
but like how close is the guess?
Depends.
Okay.
Well, I'll show you an example in a second where if you have a bad guess and you're not close enough. Let's just say it now. So like, go and look at this graph right here. So we're looking to get R, right? We picked x1 as our first guess. So we get x2. We do that and get our second guess. We got further away. So if you start seeing, when you run your Newton's method, if your answers are diverging, they're not getting closer to something, what did you know? You had a bad guess. Go back and try a better guess. Right? That's all. Is that okay? Now, sometimes it's really sensitive and you have to be like really close to get it to work. But most of the time they're relatively well-behaved functions and it's usually not that big of a deal. But my method or my reasoning for wanting to pick 1 here is just because arithmetically, that's less of a hassle to plug in. Like it's just less decimals. It's less, if I had to do it by hand, it's less stuff to do by hand. So I put my guess in, go back and recap that setup, and then just grind through this. We want 6 decimal places correct. So what do we got here? 1 decimal place correct. Now I got 3 decimal places correct. And now I got 7 decimal places correct, or 8 decimal places correct, or 9 even, I'm sorry. So I'd be done here at 939.085. I think that was the 5th one. 739, was it 085? Yeah. That's the gist of it. How is this for like the easiest section of the chapter?
Yeah. Yes.
It's like computationally it's even easy because your calculator is going to handle it.
So
And-
it's like, so this setup is what, like when you graph an equation, that's like the setup that it does.
That's how you solve for the x-intercept, that equation.
Yep.
That's how you solve for the x-intercept for the tangent line. I skipped the algebra deriving that because we had 30 minutes and I want to make sure I did the examples and did the calculator setup because that's the part that really matters.
Yeah.
But I think,
Is there a way to like copy and like paste equations into, let's just say, a program for research? How do I save this?
I don't on yours. I don't know that they're.
Because like when I like clear, like I like clear my memory a lot.
Mm-hmm.
Because I don't know. Because why not? But like, is there a way that I can keep this, or because like I can keep this in the back of my head, but it's like, why keep it in the back of your head when you can just keep that?
Yeah, I don't think yours can. I know if you have the CAS one has a different operating system and can do cut and pastes. I don't know that these ones can.
Okay, I'll just don't you worry.
Yeah, you could do a Google and see, like, I'm sure like a YouTube search if you can do it.
True.
Somebody will have a video on YouTube of like cut and pasting with TI-84 calculator.
Yeah.
You know. Mm-hmm.
Do you recommend the TI Inspire? Do you think it's a good calculator?
What I would say is if you're like, I'm going to be an engineer, I'm going to do a lot of calculus for a long time, it's worth having a CAS calculator.
Okay.
You'll be happy you have one, even if it's just for like checking homework, where it's like, yeah, I have to do this by hand. I can't use it on the test, but Lord Almighty, it's helpful for checking things.
Yeah.
It's probably worth it. If this is the last calculus class you're probably going to take, I would say no.
Yeah.
I think it is okay to use on the AP exam. I Googled that when I saw that some of us had them. I believe it is, you can use it on the AP exam. So
Costs a lot of money.
it is, they are very,
Yeah.
it is very expensive.
I was like thinking like maybe I should like, because I don't know how many calc classes I've taken in college. I was thinking about sinking some money into it, but it's like, I don't want to if I don't have to.
Right. Yeah. I mean, if you're going to take, if you're going to be an engineer, you're going to do Calc 1, 2, 3, 4 differential equations. Mm-hmm. Like you're going to be doing some calculus for a long time. It's probably worth the investment. If it's like, I don't know what I'm going to be doing, then you probably just kick the can on it. And if you end up in that road where it's like, I have a lot of calculus to do in my future,
then
it's probably worth it. Or if you're going to be like, like a scientist, where you're going to be like a chemist or something, like, or even certainly a physicist. You obviously can do the calculus, but even like a chemist, you think you'd be worthwhile having it. Just at some point you'll do the PChem and you probably have to do up through Calc 2, maybe Diff EQ also.
Diff EQ.
Differential equations. Because that's like most, like your modeling kind of runs in, like falls under that.
Yeah.
Like if you want to create the model for an atom or whatever.
You can do that?
Yeah.
Oh. Like a model for, because isn't like an atom like not possible to model? Isn't that like a thing that I learned?
So it's a probabilistic.
Oh, okay.
Like, so it's like, now you're talking about like calculus, like the Bohr model for an atom is something that I did as an undergrad in a chemistry course where we derived the Bohr model for hydrogen, which was like 2 weeks of math.
Oh, wow.
To kind of build up to and do, but like that was something that I did as an undergrad.
Did it work? Like were you successful in your
well, it's really
creation?
like what you get out of it is you get like the quantum numbers for hydrogen, which we already knew. But it's like, yep, and there's the answers that you get. Look, those are the quantum numbers you already knew. It's like, it's kind of unfulfilling.
So it's you don't get to like look at like the screen as it like lights up in a little model.
No, it's not going to be like a visual. It's like an equation that you'll be solving. Yeah. It's not a visual model.
Dang, I thought it was gonna be like when that lady like took like